The following is a keynote speaker presentation from the ACM 97 conference, The Next 50 Years of Computing. ACM 97 brought together over 2,000 leaders and luminaries from all aspects of the computing world to discuss and predict what the next 50 years of computing has in store. ACM 97 underwriters were Computer World, Hewlett-Packard, Intel, Microsoft, and Sun Microsystems. Sponsors were Cadmus Journal Services, IBM, Netscape, Popular Science, Sheridan Printing Company Incorporated, Silicon Graphics Incorporated, SoftBank, and Unisys. The event also included a major exposition with a paleotechnic look back to the future from the year 2047, and a specially commissioned book, Beyond Calculation, featuring essays on the next 50 years of computing by luminaries and pioneers in the field. The ACM 97 conference was chaired by Robert Metcalf and emceed by James Burke. Details on how to obtain more information on ACM 97 follow this program.
Ladies and gentlemen, James Burke.
The next speaker this afternoon got his PhD at the University of Massachusetts at Amherst in '78 in computer and information science. From '81 to '88, he taught at Yale in the departments of psychology and computer science, and since '88, he's been associate professor at the University of Michigan, both in the School of Education and the Department of Electrical Engineering and Computer Science, and he's also professor of information, libraries, that is. And since his first degree was in philosophy, he's what we might call a well-rounded chap, and as you'll see, in more senses than one. He likes good food like me, that's all I mean. He holds a number of extremely distinguished teaching awards. He's published more stuff on AI and education than you could shake a mouse at, including a couple of pieces that caught my eye. One called How the Nintendo Generation Learns, and another one, Beware of Techies Bearing Gifts. His particular concerns, I'm sure you've guessed, relate to how learners of all ages and stripes will be able routinely to use computational media to achieve their goals over the next decades. And he's put his money where his mouth is. Media Text, an award-winning multimedia composition environment that's in use in hundreds of classrooms around the country, was designed and developed in his lab. He's editor and co-founder of Interactive Learning Environments, a journal devoted to exploring next-generation technologies for teaching and learning, which is what he's going to talk about and what you're going to learn about in a moment. There will not be a test. Now, I want to say one little extra thing. Normally, these conferences, one is impressed by how all people at the top of their field are terribly cool, laid back, charmingly laid back people. It was absolutely endearing to see this chap who's at the top of his field over the last day and a half, jumping up and down and panicking. Ladies and gentlemen, to look at the impact over the next 50 years of information technology on K through 12, 97 through 47, here's Elliot Soloway.
Thank you. I am round. What are you going to do? You've all gone through education, 15, 20 years of it. So you probably in your heart of hearts feel, you know education. You know, for example, you remember the good old days. You think back to, well, when I went to school, it worked for me. If school would be just like that now, it would be okay. And the other day, Gordon said, anything that's cyberizable will be cyberized. And think about it, though. Do you want your kid to have virtual friends in a virtual classroom with a virtual teacher? I mean, we can do that, but do you want that for your kid? Now, one more. What if you come home one day and your sixth grader, you realize your sixth grader is reading at a second grade level, but is a whiz with images in Photoshop, is a whiz with HyperStudio, is a whiz with Director. Are you going to hit the ceiling What are you going to say to your kid? Well, in the next 30 minutes, I'm going to try to talk about those kinds of issues because those are the issues that we're going to face over the next 50 years. And we've got to think about your children. Now, the title, Educating the Barney Generation's Grandchildren, a couple key words. Barney, you know, the big purple guy, right? And in the Barney generation, take your 5, 6, 7-year-olds, like my daughter. My daughter thinks a house comes with a TV set, a bathtub, a telephone, and a computer. I'm bored, Pop, let's do kid pics. For her, when the computer crashes, she doesn't take it personal, she starts it over again, right? For most adults, they do take it personal. For the Perry Como generation types that, you know, raise your paddle, do you know who Perry Como is? I mean, it's, right. For most of those folks, they don't feel comfortable. Now, it's going to be very interesting. As my daughter, as the Barney generation kids go up through school, the kinds of demands they're going to make on education for use of technology is going to be very different than the current kids. And what happens when the Barney generation becomes teachers, when they start teaching kids? How are they going to feel about technology? Well, I'm going to make an argument today. 3 steps in the argument. First, what is an educated person in 50 years? And I'm going to try and make an argument that we need to change the current pedagogy. Right now, we do didactic instruction. Someone stands up there and tells you stuff. No, that's not the way we're going to need it for the next 50 years. What are the roles then of technology in facilitating that new pedagogy? I'm going to make a very strong argument. I think that without technology, you will not be able to implement a pedagogy that will support kids in developing deep understandings. You have to have the technology. The third thing is what is the role of technology in transitioning to that new order? And I think actually technology can play a catalytic role in a clever sort of way. So, first, even before World War II, our educational system was producing real good folks for the industrial age. Obedience, punctuality, attendance, those are the kinds of things that our educational system put forward. If you look at the classrooms, there were rows. There were rows in factories, there were rows in classrooms. That's in the blackboard jungle. You know, the kids are not bothering to look around. I mean, look at the teacher. They look around. That's what we went through school, right? And you ask the question, what is a test in those days? A test is to see if you could repeat back to the teacher what the teacher knows. Why? Because on the assembly line, you don't need imaginative, original, creative thinkers. You need folks who are going to respect authority, who are going to be reliable, and who are going to be on time. That said, you know, Paul Simon said it. When I think back to all the crap I learned in high school, it's a wonder I can think at all. But the reality is right, look how successful he is, and look how successful you are. How did that come to pass? How could you have been so successful? Because you're the top 20%. This talk actually isn't for you. This talk is for the other 80%. You're going to succeed. You folks have succeeded, and probably your kids are going to succeed because they're driven, they're supported, you're going to do whatever you can to make them work. And your parents did the same thing for you. They supported you, they got you the books, they got you the tutors, they got you whatever it needed to do to be a success. Paul Simon's a success in spite of the schools. Now, we're starting to make a new transition to a new kind of order. We're dealing with a process economy, not a product economy. Lester Thoreau talks about the fact that after World War II, all you needed were entrepreneurs, a few entrepreneurs. It was okay to educate only the top 20% because that's where the ideas came from. However, now as we transition to a process economy where faster, better, cheaper is important, we can no longer afford to educate only the top 20%. We have to educate 100%. Never before in our history, in the history of the world, have we attempted to teach and educate 100% of the kids. That is an amazing goal. But yet, over the next 50 years, if that's what we're going to try and do, then we need a different kind of pedagogy. Now, what kinds of things do we need? Well, even our Republican governor of Michigan had it right, it seems to me. Kids need to be able to solve hard problems without needing to be led by the nose. They learn to be able to learn new things on their own, and they have to communicate with their coworkers, their peers. Now, it's interesting. You can't disagree with those 3 goals, but I defy you to find those 3 in any state guideline in the 50 states or around the world. Those aren't there. What's there is photosynthesis, Avogadro's number. That's what's there, not that. Well, What is that pedagogy? The pedagogy is the pedagogy your mother knows, that John Dewey knew. When my mother used to say to me, don't just sit there, get up and do something. When I got up and I did something, I took ownership, I took responsibility, I learned. When I was an active learner, that's when I learned something. Then she used to yell at me too, don't just do that, think about what you just did. Right, reflect. All the data, all the evidence is that learners who reflect on what they do are successful learners. There's a term, metacognitive skills, whatever you want to call it. But the point is if you step back and reflect on what you've done, then you will be a successful learner. You know kids, you know maybe coworkers, who don't do that, who just do but not reflect. John Dewey, turn of the century, actually from University of Michigan, he did his early work there. He put forward these notions of learn through doing, but you got to be real careful. It's learn through direct experience. You don't want to learn about science, which is what we have taught kids up to now. You need to do science. Now we got to be a little careful though. It's not just hands-on science. You did hands-on science in school. You went into the chemistry lab and you followed a set of cookbook instructions, like, Avogadro's number, 6.2 times 10 to the 23rd power. I was off by hundreds of orders of magnitude, right? But what does it matter? The answer was in the book. Who cared whether I got the number or not? I got to know my lab partner. She was fun. But otherwise, what's the point? What people are saying now, and this is out of all the bodies, the American Association for the Advancement of Science, the National Research Council, they're all, and in social studies, in mathematics, National Council for Teachers of Mathematics, they're all saying the same thing. We have to stop didactic instruction and talk about sustained inquiry, where kids ask sincere, deep science questions. What is the quality of water in the stream behind my school? That is an authentic, interesting question. It's an authentic question to the kids. You could teach all about the different states of matter, different kinds of energy. It's a sleeper. It's an absolute sleeper. But you could say, where does my school waste energy? Ah, that's interesting. You could teach about ozone, which again is a sleeper. Or you could say, should I wear sunscreen? That turn, that way to twist it around into a driving question is what changes what the kids are going to do. It motivates them. And if you have children, you know, if the kid doesn't want to do it, the kid's not going to do it. If the kid's motivated to do something, they will do something. All the standards are coming out and saying the same thing. Fortunately, we do have the new standards, and it's driving changes in tests. Michigan, for example, the state Michigan test is now beginning to change. It may take 50 years. It may take 50 years to get these standards percolated out there and everywhere. Well, this is what a classroom could look like if you do inquiry, sustained inquiry. Now, I'm going to show you existent things because even though I'm talking about 50 years, because it will take upwards of 50 years to get this out into every single school. Now, this doesn't look like the classroom with rows and stuff like that. About 5% of the time the teachers lecture. Good lecture's okay, benchmark lesson to sort of get people motivated, that's important. But kids in these kinds of classrooms that are doing sustained inquiry do projects for a whole semester. They'll ask the question, what is the quality of water in my stream for the whole semester? The biology, the chemistry, the ecology, the geology, all underneath that one driving question. And critically important will be the technology. If you're going to ask kids to do sincere investigations, they're going to need new sets of tools. You got asked, I remember, right? We all got asked, write a 2-page report on such and such. What did you do? You went to the encyclopedia, copied it down, and you handed it in. Of course you do that. Or now you go to the internet and turn it in. It's the same thing. But if you have to write, what is the relationship between pH and water quality? Why is it the way it is? You need a new set of tools. In classrooms, you have 40 books, 40 copies of the same book that's 8 years old, right? How are you going to really go deep into a subject matter? All the standards are saying the same thing. They want kids to go deep into some area, and they'll sacrifice breadth because they know the kids don't learn the breadth anyhow. So, given that we need a more inquiry-based pedagogy, which is straight John Dewey, which is straight what your mother used to say, what is the role in dealing with what is the role of technology in supporting that? I'm going to try and take, again, a strong argument. Fred Brooks in the No Silver Bullet paper tries to say, what are the fundamental problems with the essential problems in software? And let's see if we can deal with that. Well, I'd like to sort of try to identify some essential problems in education and see how technology might be able to deal with it. There are 4 elements in an educational system: the school, the community, and there are 2 kinds of processes, learning and teaching. And I'm going to try and take one problem sort of from each of the areas and try and say, this is an essence problem, how does technology deal with it? First, school. Well, the fundamental issue in school is how do you ensure a healthy, caring relationship between students and teachers? I'm not a Luddite, I believe in the technology, but in this particular instance, I don't think it's good. I don't think we need the technology here. If you look through the ages, you'll see pictures in Greek, in the Middle Ages, in the shtetls in Europe. You're going to see the same thing over and over again. Teachers with kids working together, building a relationship. Mr. Holland's Opus. Mr. Holland's Opus is a tearjerker, right? Why is it a tearjerker? Because you can relate to it. If you were lucky, if you were fortunate, you had a Mr. Holland who looked out after you, who took care of you, who looked for your interest. Over and over and over again, the statistics are absolutely clear. When kids have parents or guardians that advocate for them to the school, those are the kids that succeed. And there's a new term they call social capital about what happens in urban settings, that they don't have Uncle Harry that can get them a summer job, or they don't have Aunt Sue who's going to go to the school and argue why they should be in a class. Those kids that don't have an advocate, that don't have a relationship with an adult that cares about them, don't succeed. Now, similarly, student-student relationship. What's that all about? It's about democracy, right? It's about going to school with kids that don't look like you and don't think like you, but you got to get along. And you practice for 12 or 14 years trying to get along with kids that you don't like, you think you're kind of idiots, but you try and get along. The danger to the technology that I see is it'll be very easy to create classrooms where the kids all look the same, they think the same, they're all like you. And in a way that is maybe more comfortable and maybe that's easier, but that's not what school is about. School is to learn how to get along. Now, that said, sure, you can use the technology. Of course you can use the collaboration technology, the network technology, what have you. But please, we've got to be very, very careful. If you can't rub shoulders with that teacher and see that teacher every single day, not once in a while, not quality time, but quantity time, you have to be able to see that person because that person cares about you. That's what's important. Second problem, community. Sort of the educational essence problem is support learning in context. Right now, schools are divorced from the real world. Kids think that science is done in the lab in room 301 upstairs. They don't see that science has to do with their everyday lives. But yet the whole point, what we do is we see that it does have to do with our everyday lives. Schools are not connected to the home. You go home and your parents say, well, what's your homework today? And maybe you'll have a sheet, maybe you don't have a sheet. But what's going on in the community, what's going on in the home, isn't particularly relevant to what's going on in school. But that's really wrong. There's got to be a relationship between the home, the community-based organizations, the businesses in the local community, and the school. So, for example, one technology, the tricorder, where that thing that the Star Trek folks had, where you pointed at something and you can gather some data. Now there are these laptop, little tiny computers, the e-mates, what have you, all these little machines that you can go out to your rivers and streams and collect data. No longer are you forced to do the experiments that are in the book. No, you frame your own problems, you create your own experiments, and you can go out and collect data now that's very different. You learn in context. Similarly, if you look at schools, right, they're isolated from all the other kinds of buildings. But with networking technologies, what you can have is interesting kinds of mentorships, interesting kinds of internships. I know it sounds like it's a trite one, it takes a whole village to raise a child. But it's true. It is true. You need all those different sorts of folks to be there. What we're trying to do, for example, is it turns out that in urban setting, asthma is a problem for kids. Well, it turns out that it's a public health problem. So we have folks in this area in Detroit that are working with Latino Family Services, and the parents are very concerned about asthma. So working with the schools to say, well, can't we do a curriculum unit on asthma? Because it'll tie to the state guidelines, but it's also interesting to the local community. We're trying to use this web TV stuff. It's just a networking technology to hook up the homes so kids, you know, when they have asthma, you have these little meters. You puff into it and you measure your lung capacity. So at home, you do your experiment, you collect your data and compare it to the other kids in the class. Trying to bring the home, the community center, the school, all together so people are involved in those kids' lives. Well, what about learning? This is going to be a Nancy one. Literacy has got to be the basic core, right? The basic issue. We've heard a bunch about literacy, about storytelling, and about the new technologies. And you think about computational media, what it affords. What kinds of stories does it enable you to tell? How do you express yourself? That's what drives people, is the ability, the need to express themselves. How does computational media do it? Well, you know, you have your old books, the McGuffey readers, what have you, and you have your new books. And by and large, they're the same as the old books, except they got some color. But now what you got, right, basically what you got, this is my Make-Believe Castle. It's a tool that allows kids to create interactive, dynamic stories where the characters interact, but you don't need to program. Well, you do have some proceduralization. You have to specify one thing interacting with another. The dragon, for example, slipping on a banana peel. What kind of story can you tell with this? Should you have words in here? Well, Pappert's quote, "For the next generation or two, one must expect literacy to include some letteracy. Since our culture's past is so connected with expression through writing, it will not follow that learning the letters should be the cornerstone of elementary education." Come again? Wait a minute. You don't need to read? Wait a minute. Now we're off the deep edge. But maybe turn it around. How many kids do you know are not particularly verbal? We're successful because we're verbal, right? My kids are verbal. They can deal with the stuff, right? Right? But you know kids that aren't, that are good at the mathematics, they're good at the chess, they're good at the art, but they're not particularly verbal. Why is it that we start with the verbal and then move on? And what happens to these kids, my son has a friend, he's in 7th grade and he's reading at 3rd grade level, but he can beat your rear end at chess. He's real good, but he struggles with the reading. He can't do the reading. And he started out and he's struggled every year with it. Why can't we turn it around? Why can't he start with the nonverbal stuff and get really comfortable with that and be successful in creating stories with these kinds of computational media and then move to the verbal? Why can't we use it that way? Where is it written? We could do it that way. Well, what about another thing with learning? Dealing with complexity. All the standards say we can no longer start to teach these kids all these isolated, decontextualized skills and assume they can all put them together. That's how we went to school. They take a complex task and you drill on each of the skills, right? And then there would be an assumption that you could put them all together when you needed to. Not a chance. Not a chance. Now, if we want to ask kids to build models of complex stream ecosystems, for example, we have to give them new sets of tools. So let's think about software and let's think about learner-centered design. Every speaker's got to have this curve. I got this curve. But I broke it down a little differently. Have the Zorch factor, right? Whatever the power of that machine, the Zorch, right? And if you take it up to about 1975, basically it was technology-centered interfaces. There was barely enough Zorch to do the task, so you did whatever the machine wanted. After about 1975 to, 1995, there arose a new discipline. We talked about user-centered design, because finally there was enough Zorch in the box to do two things, to do the application and to run the interface. And there was a seminal book, 1985, Don Norman, Stephen Draper, talked about user-centered design. Well, now, Zorch, we got plenty. So why can't we do it learner-centered? Why can't we do something a little different? Learners are not just short users. They have unique needs that are different than users. And if in fact you try and design a learner-centered interface, you'll design it differently. For example, learners grow. Day 1, they start. On day 180 at the end of the semester, they're different. They learn something. The software stays the same. It's the same on day 1 as it is on day 180. Why? Why can't the software change? Second, motivation. The kids go and play these wonderful video games and all that great stuff, right? And it's wonderful. Then they look at educational software and they go, blech. Why would they do that, right? No, they've got to have it. The software must be engaging. Third, diversity. We treat kids as if they're all size 12. They take the same textbook and they read the same pages on the same day, all in lockstep. Each of them is radically different. Some of them could do the lockstep, but for a lot of them, they don't get it. Why can't the software be very different for different kinds of kids? We can do that. We have the Zorch to do that kind of software. Why can't we create it? And you sort of step back and say, well, what's the fundamental goal of user-centered design? Ease of use. Make it easy to use. Good goal, good goal. Nothing wrong with that goal. Learner-centered design has a different goal. The learner-centered design goal is to develop expertise. That's the goal of learner-centered design. Ease of use is part of it, but not everything. You want kids to be able to develop expertise. So you build in scaffolding, and then you fade it as they develop more expertise. So for example, this is a tool that can let kids build models, not simulations, just simulations, but models of complex stream ecosystems. Normally you need to build a model of a stream ecosystem, a differential equation. You're not going to get 9th graders or 6th graders to do differential equations. I mean, the way we tell kids, right, is spend 3 years and learn this stuff, and then you will tell you how to use it. Right. Not a chance. Not a chance. So what kind of scaffolding can you build into the software to let them do something? For example, when they see this program on their computer, the kids in Ann Arbor in particular, they go, oh, that's my stream. I put my feet into that water for a whole year and measured the water. I want to know my stream. I want to understand my stream. Now, it's not just anybody's picture. I've had my interface colleagues say, oh, it's a big pic. What do you need a big image like that for? You missed the point. It anchors the kids. It provides them a context in which to understand what they're trying to do. Well, how do you get around differential equations? Well, kids can construct English sentences. They can say stuff like, as the pH goes up, I can't read the slide, so I'm going to make it up. As the pH goes up, the water quality goes up. And underneath, there's a differential equation. Turns out that the graph will match the English sentence, but the kids, when they start, they don't get that. They can create those English sentences. And what you find is they create fairly complex models. I mean, these aren't, this particular model is a eutropification of some sort. And this isn't rocket scientists. They're just 2 young kids trying to build a model, understanding the relationships. Now, interestingly enough, this is different than the SimCities, because in the SimCities, for example, in those kinds of simulation programs, you can increase, for example, a tax structure, but you can't introduce a whole new tax. You can't do that. That's simulation. But in modeling, you can introduce new tax, what have you. Interestingly enough, without a program of this sort, without the technology, kids would not be able to do the essence of science, building models. Without this kind of support, without this use, without the software, they couldn't do something that was critically important to understanding science. Well, I have a table here, and there's something about teaching, and I won't go into it, about professional development, which is an absolutely critical piece, an essential piece. But basically, there are all these problems, and if technology could have an impact on those problems, my God, we really could have a dent on education. We could make an impact in the educational world. But, Technology, to a first-order approximation, has had zero impact on education. By and large, we still take a piece of stone and write against another piece of stone, right? And it's a little dusty, but it's a pretty good technology. It's a pretty good technology. But by and large, has no impact whatsoever. It's a great quote from Edison. There's a lot of these, but this is a good one. I believe that the motion picture is destined to revolutionize our educational system, and that in a few years it will supplant largely, if not entirely, the use of the textbook. Not a chance. Not a chance. That was how many years ago, right? So if we want to predict 50 years, will these kinds of tools that we're talking about be there in 50 years? Well, it has to change. It has to change. Why will it be different? Why will it be different? Why will the predictions that will use the technology now be true? First, availability. Cost. Cost is always cited as a problem. Schools will never have enough money to buy enough computers for all the kids. No matter how many bond issues you pass, it will not happen. The only way it's going to ever happen is if the home buys notebooks for the kids, just the way they're doing it now. Now, the notebook will be a funny notebook. It'll be a computational notebook, but it's just a notebook. And if we have to figure out loan programs, what have you, so kids, every kid can have one, that has to be the toppest priority of our legal educational system. Everybody's got to have one. Second, and this is a deeper reason, up to now, by and large, all the technologies have been one-way technologies, telling technologies, VCR, TV, radio, camera. I'm a professor. I get paid to profess. I like to tell stories. I don't need my technology to tell stories. I'll do it, thank you. But I could use help in the classroom. I could use help in the classroom when I got 30 kids and they're working in pairs and they're all doing different things. They need support. I can't be there with all 30 of them. So I need interactive technologies. That's what's different about today than before. That's why there's a potential that this technology, in fact, will be able to make the change. Well, let me wind up with the following. This is very upsetting when you see this on the cover of a nationwide magazine. Everybody hates school. Could this be true? Could we have gotten to the state of affairs where everybody hates school? How could this be? Well, something is going awry. Something profound is going awry. And there are all kinds of suggestions on how to fix education. Some folks say, public education's finished. You can't deal with it. Blow up the schools and start afresh. Use commercial outlets, what have you, and they'll start schools, and that's the way to do it. I think that's really, really wrong. And there's got to be other ways to do it. Now, I'm a techie, so I'm going to think about it, how I can use my technology to make an inroad and make a change. So we've all heard the parable of the Trojan horse, right? Where there were things inside, right? Well, technology is really the Trojan mouse. I mean, this is John Richards' line, actually, from Turner Broadcasting. Wonderful man. And his observation is this. Look, it's just boxes and wires. It's just boxes and wires. Things that make change are people. But what's very interesting is the following. People all agree kids need the computers. Whether they're liberals, they're conservatives, they're Democrats, Republicans, what have you, they all agree on that. And what you're seeing is people coming to the table and talking about the technology, saying, yeah, let's work to get our kids this technology, net days and what have you. All sorts of folks coming together to make a change. Now, what's interesting is when they sit down together, they discover, in fact, that they agree on lots of sorts of things, and they want to do something about education. So, in fact, one way the technology can be there is as a catalyst. Well, let me wind up by making a plea about public education. And, you know, in democracy and capitalism, right, we have companies, you have all kinds of organizations. But the premier organization, the cornerstone organization in a democracy must be public education. It's the place where everybody comes together. They don't look alike, they disagree, but they come together. And the ideas that we can now get rid of public education in favor of some other mechanism really is scary because it attacks the fundamental core of what democracy is about. Now, my parents came to this country in 1946. They didn't speak English. My native language is not English. I stand before you today because I went to a public school, Because the teachers, the parents, my parents said, you will succeed. And the teacher said, you will succeed. Well, it's sort of payback time, right? Our parents did it for us. Our teachers did it for our generation. We've got to do it for the next generations. Thank you.